All right. So that aside, now we have a good theory of why things move, or how things move, I should say, right? The theory is it requires the central player is the idea of a force, all right? So we'll learn 4 things in this simple chapter. Well, the first thing is we'll always start with the definition when we learn something, right? So what is a force? Just like when you learn vectors, you'll learn that what is a vector. We'll talk about that. And then we'll see what does a force do, right? Or do to objects. How does it affect the objects, in other words, right? Does it change its direction? Does it change its speed? What does it do? And then we'll focus on these 2 first questions in this video, and then we'll look at the different types of forces that exist, and then we'll look at how do we find out all the forces, how that is exerted on an object, right? So if I tell you, well, I'm standing right here, so what are the forces on me? How do we account and tabulate all the forces? How to find all the forces on a given object? And that will be the starting point of analyzing why things move, okay? All right, so let's start with what is a force, okay? So we'll start with the definition, right? The force is very, very simple. It's basically a push or a pull on an object or on a system, okay? So if you look it up in the textbook, this is one of the simplest definitions you'll see. A push or a pull, right? Basically, that's it, right? Either a push or a pull, but let's add some fine prints to it. As you'll see, this is a general thing in learning physics. The definition, I usually like, this is the way I learn it. I like to take a long and complicated definition and break it down. What's the important part and what's the fine print, right? So the important part, even if I cover up the fine prints, it's a push or a pull. That's a force, right? If I push against the board, that's a force, right? But there's a fine print, it's on an object, or a system. Let's just say a system. Okay, so what is a system? This is definition of a force, right? So what's a system? Okay, a system is, it can be an object or a collection of an object. Collection of objects. Okay, so it's either an object or a collection of objects. Okay, that's a system. Okay, just some shorthand note-taking notations for you. If you see I write an equal sign with 2 dots, that means definition. Okay, so this is a symbol for this. This is the definition of this, or this is defined as this, right? So just to emphasize that, I could have just written equal, but just to emphasize that. Now let's clarify what that means is, right? So this is just to be really formal, right? That's why it's a fine print on a system. So every time you talk about a force, it has to be on something. And it also has to be by something. All right. On a system, maybe I should clarify. Sometimes the books don't write this, but I'll clarify this by a source. Okay. So for example, if I'm pushing against the board like this, the source is me, the system is the board. Okay. A system is an object or collection of objects because, for example, if I push a book or a block like this, so if I push it, right, I'll move it that way, I'm pushing on an object, but I could also be pushing a stack of blocks, right, or next to each other, right? I can push this, right? You can think of it as a whole system. So system is just the formal word, the technical word of a bunch of objects that you're going to analyze it together. I'll just consider the force being applied to everything equally. If they never break apart, then that's it, right? Okay, we'll see examples of this like this. For example, if there's a truck pulling a trailer like this, moving, right, we can sometimes analyze that as a system and analyze what are the forces on this whole system itself. It doesn't have to be one object itself. So that's just being a little bit pedantic and a little bit more rigorous, a good way of saying that. And by the source, in this case, it was by a hand. If this guy is moving by engine, you know, the engine can be the source like that. Okay, now I want you to notice one thing. If I push something, I can push it with different amount of strength, and I can push in different directions. What does that suggest? We just learned something that exactly this requires that has a magnitude and direction. That's right, it's a vector. So what I'll point out that this is almost one of the archetypical examples of a vector. Okay, so as you notice, a force is a vector quantity. Right? This is what we say. Right? You'll hear this word a lot, quantity or vector quantity or scalar quantity. A quantity is something that's measurable. Okay, it's our jargon or technical terminology that is a measurable thing. Okay, something that's measurable. All right. So if you go into the lab, if you need to do some physics labs in the future, right, or in the science, things that you measure, these are just called quantity. All right. So a force is something you can measure, but it's also a vector quantity. That means it has a magnitude and a direction. Every time you talk about a force, in principle, you need to tell me both. What's the magnitude and what's the direction? Sometimes we're lazy, we don't say it, but if someone pushes you and interrogates you, you need to be able to tell them exactly what this is, right? So you've heard of, for example, gravitational force. I can tell you how strong that is and also in which direction, in this case, going towards the ground, right? So it has a magnitude and direction. Direction, we learned exactly how to describe that already, you know, like 30 degrees north of south or 30 degrees clockwise from the positive x-axis or something like that, right? You learn about how to talk about directions. For magnitudes, let's specify that a little bit more. For force, there's no such thing as length, even though we can describe it or draw it like an arrow like this. And we'll graphically, I'll represent the arrow. The larger the arrow, the larger the force, the larger the magnitude or the strength of the force. But we don't measure it with meters, right? That's not the way we measure force. We have a special unit for it. The unit is measure it in newtons. Because Newton was the British guy who did a lot of research and wrote a book on it. We start using newtons as a quantity, and we'll just shorthand it with capital N. So we'll talk about this is a force of 1 Newton, 2 Newton, 1,000 Newton, 0.1 Newton, whatever. Okay, so just to give you a sense of what a Newton is, and 1 Newton is roughly the weight of 1 apple. Okay, so roughly 1 Newton is roughly the weight of 1 apple. Okay, just roughly, you know, apples can be large or small, they can be heavier or lighter. The proper definition of what counts as 1 Newton, there's a piece, well, it used to be, if you're wondering, there used to be a piece of metal that's now stored in a museum in France somewhere, and that little piece of metal is the universal agreement, agreement of that's 1 unit of Newton, right? And everyone can go and you can put on a balance and see, oh, if I need 2 of these metals, I can first make sure I have another block, right? That is exactly, I can put it on just a simple pivot like this and put that international standard of 1 Newton, right? I can put another object and go like, oh, okay, they balance. So this must be 1 Newton, right? And I can put it over here. And if it balances a bunch of books over here, right? Then now I know that the books are 2 Newtons. And that's how you can start measuring the forces of different things like this. We'll start to talk more about that. And let's move on to the second point first. Okay, what do these forces do to objects?